Hi there, Mr. Automation is back with some data science again with Python on the REVM COVID data with Jupyter notebooks. See some nice screenshots here of the data we're going to investigate today. Let's go to the slides. Will be a lot of doing again. I'll just make a small summary of what we're going to discuss, and then it's only doing, so to speak. So bear with me a little bit. So we're going to analyze the data from the Netherlands that we get from the REVM. It's a central institute here in the Netherlands that collects that data and provides it to the government as well. So we use that data as well. It's the same data, and we're going to do some analysis on that with Python data science modules. Basically, we're going to import a CSV file from an URL. I'll show that in a second. We're going to display some information about the provinces. We're going to create some nice reports about per province, for instance, so like the deaths and the hospital cases and such. And then we make some death versus hospital. There's no relation, by the way, but we can at least visualize the counts, so to speak. So we're going to do that in a table. We're going to do that in a bar chart as well. We're going to zoom a little bit in the top 10 cities in the Netherlands, so which one have the most cases, so to speak, and perhaps even the death rates there. We can perhaps see some relation there. So we go, and that means we're going to do some calculation on the data we got from REVM. So we're going to basically add our own columns and do some calculations and present those values. And percentages in a table in the bar chart. We're going to use quite some techniques today. We do selections. We're going to group some information. We're going to add columns ourselves to the table. We're going to create a table or a modified table. We're going to set some formats in the table. I'll show you as well how that works. And we're going to do calculation on whole columns of data, right? So we can do a sort of a function calculation on that, and then you get like a nice list back, and you can add that basically as an extra column to an existing table. Okay, I think it's enough talking. Let me launch Visual Studio here. Visual Studio Code, by the way. Let's see. It's in the wrong window, of course, so hang on. I'll drag that to here, and I'll do Ctrl-Shift-P, and I will create a new blank Jupyter notebook. And I already copied in the sort of the boilerplate code you always need, like the import of the data science. I explained it in the last video already. I'm not going to do that again, but see it as a boilerplate. It's needed for the rest of our investigation, so to speak. That's a sort of the framework we build upon, right? Those data science modules and some array stuff here as well. Let me open a browser here. Let's go to the COVID data set. This is from our national institution, so to speak, and here are the input files you can use. And we're basically using this one, this CSV file, I think. Yes. What you can do, you can copy the link address here instead of downloading. You can of course download it and then refer to it, but I use this tool almost every day to do some analysis, or sometimes I don't use it a couple of days and then I'll do some investigation again, and then I don't want to download the file every time. So what I did, I'll show you how that works. I created the URL variable, and there I have the CSV file inside of there. So when I run my code, I always have the latest version of the file, because it gets updated each day at around 5 o'clock, I think. It's here. Somewhere here at least. See, so it's I think about 3 o'clock even. Then it's updated every day. So what we can do now is, for instance, we run this, and it's still running. You see the asterisk here sort of spinning. So now we have that data from the REVM site, and we have it now in this variable nl. And what we did there was read the table based on the URL. And this CSV file is separated by, that's the delimiter. So I'll specify that, otherwise the import will fail. And now we have some data here in NL we can work with. You see that? So we have all the data of the NL now here, and this is basically, we're going to build upon this. I'll remove this one, create some real estate, add a new line there, and we'll create a small report on the provinces. And I prepared it a little bit because it's quite boring if you see me typing these kinds of syntaxes. I can type properly, but but still it takes like 30 seconds or a minute to type. It's a waste of time. So, but basically what we do here is nl, right? This table. We do a select on that, select on the province and the total reported. And what we do is where the total reported are above 0. I'm not interested in 0 values. So if I run this and I do all reported provinces here, so now we have a sort of a sum here, all the provinces, and I think we can even do a plot on that directly. Not sure. No, that doesn't work, but I'm quite sure. Can of course do a barh, bar with a header. Which header? That will be a province. See? So now we have like a sort of a bar overview of the same data, of that data. Okay. Perhaps I'll leave both examples in. I mean, I'll leave this one in, and then I'll copy this one over. I'll create a new cell there. Scroll down a little bit, create some real estate, and we also do the bar version. So we have now this information in the bar. You can even sort this, of course, you know, on the count, and then you have the highest up and the lowest down. We do that later. You will see how that works with the sorting. So let's see what we can do now. Yeah, let me create a new cell here. Below here, I'll scroll down a little bit, create some real estate again. And what we do now is based on the NL set, we're doing a selection again, and this time in the total amount of hospital admissions. How many people are in the hospital and how many are diseased. And what we do here, we group that. First, I'll build it up. But this is the selection. And then you get the table back. And it looks like there's nothing inside of it, but look here, it's like another 143,000 rows. So, yeah. So what I do here, I group them on the province, on this value. And then I ask the sum of all these tables. So basically everything get counted up, so to speak. So all these values of the 143,000 somewhat rows, those get combined in one single value. And we take the sum of that, so everything is counted up. You can also get the max value, of course, but now we use the sum function for that. We do the same on the deceased. That's basically what it means here. It sums up both of them. And what we do then, we cut that still off. So let's run this now. So now we group it. It will take some time, of course. It's quite large data. So now it's grouped. And you see you only have 2 rows to show there. And perhaps if we show everything, so we can do .show there, for instance. And you see everything. See? So that's all our provinces in the Netherlands with the count. So how many people are in the hospital and how many people died in total in that province. Pretty nice. Okay. Pretty cool that we can get that data there. So what we can do as well is visualize that in a chart. You know, this is just a table, and I can do some pipetting as well here, but still, sometimes a picture says 1,000 words. So let's run that now. Let's see what we get back. Take some time, you see. This is pretty nice, I think. So if you look, for instance, at Drenthe, that's how it's called here. You see the total hospital admission and the total amount of deceased is, yeah, it's kind of almost in balance. And let's see if we get some interesting data. Oh, here, this is very interesting, by the way. We have Friesland, that is a province here. More people are dying that are on the hospital, so it's a, yeah, I can't laugh at that, of course, but the facts here are a little bit strange, I think. And that's because I also noted that here there's no relationship established between the deaths and the total amount of people in the hospital. I just draw this picture for demo purposes, so to speak. There's no relation here. So don't think that all the people here that were in the hospital also died. Lots of people died at home or perhaps in care centers, you know. Let's see what we can do more with the data. Yeah, let's add another cell here and do this. So what we do here is again a selection on the NL dataset, and this time the security region name. And then we take the total reported, and where the total reported are above 0, I mean. Let's see. We get back. We don't get anything back, by the way. It's inside of result, of course. See? So now total report, and again you see a lot of rows there. So we build this up a little bit, make it a little bit more interesting. And you make it more interesting by grouping it, for instance. And we can do that like this. So this result now we have that, alright? And we can group that, and we group that on the security region name, so that's that property, so to speak. And then we sort that on the count, and let's build it up again. So let's break it there. So we just group it now on the security region now. You see? Now we have a nice count there. What we do then is sort it on count. You see this count, and we do descending is true. See what we get back there. See? So now we have the highest on top. So seems like total reported in Utrecht, that's the highest in the Netherlands. I didn't know that. Okay, funny. And after that we can plot that, so to speak, or chart it to a bar chart. Now let's see if we do that now. This is the whole syntax, so to speak. And there we have it. And because now we sorted it on count, remember this one was a little bit messy, that, you know, those bars are not like this search which is the smallest, for instance. And here, yeah, you have like instant overview. And of course, if we set this to false, it will be in the reverse order. You see? So then it's the smallest. But I don't know why there is an NIN. That's an NIN means not a number. I didn't filter those ones out. So ignore that, I guess. Put it back the way it was, descending through. You see, Utrecht conformed and confirmed, I mean. And then we have Brabant. And then, yes, okay. Pretty nice information. Let's see what we can do more with this data set. So, because we can do more, I can tell you that. Yes, what we can do, for instance, I prepared this a little bit again, because otherwise you need to see me typing these kinds of statements, and that just takes a long time. Again, we build it up. So what we do here is I'm interested in the top 10 cities reported. So which city in the Netherlands are the most cases reported? And we build it up again. So first we do the query on the table. And it will take some time. And it is done already, and now we have that here. See, and perhaps I'll do that here in line, and I can close this one. It's a little bit neater. So let's run this one again. You see, so now we have this, and again we have a lot of rows there. That's why we group to combine them. Again, we only have one property, by the way, that has a name, so we group it on that name, and then this is the sum total reported will be counted there. So we remove that one. See what we get back. Build it up, build it up. So we do a sum, and now we get the different results, and now everything is counted up. Oh, wow, this is pretty high. Pretty cool. And what we can do then is, for instance, we can sort that. We sort that then on this new sort of column, this reported sum, right? It was created for us. And we do is descending again on that. So let's run that. Perhaps we see some different result here. I don't know. Ah, okay, exactly. So Amsterdam is and Rotterdam are the top ones, because those are the biggest cities. So I was a little bit surprised that this one was on top, but we did not sort it yet, and we did not do any descending. What we want is the top 10 cities. We still have like 343 other rows here. We have all the cities here of the Netherlands, and we're not interested in that. We only wanted to have the top 10. What you can do then is a dot take. And then you can specify a range. I do that here, a range of 10. And let's run that. Let's see what we get back. There you have it. And now we only have the top 10 here, of course. And this again is a table, and we can of course do that to a barh, set h, open and close that. And why do I put the 0 there, you ask me? I will tell you in a second. See? So it's sorted now. Basically, I'll show that again. the columns have names, right? Total reported sum, and then this municipality name, that one, and hang on, yeah, and you can use a name. You can also use an index. And what I did here was 0. It's the first column. That's what I'm doing here, and I'll show you that it works the same as you stick in the name, so to speak, if you provide the name, however you want to express that. So you can also put in the name there, and then we run it again, and you will see the same result. So we have a bar here with the top 10 cities in the Netherlands on the reports, so how many people were reported there, and yeah, pretty nice overview. Perhaps we can get a relation, percentages people dying, for instance, you know. So let's see if we can extend our demo a little bit more. Hang on. Yeah, let's group them again by province. So province grouped. I create a new table there, basically. Let's see how the table looks here. But this is a new table, and then now we have some more information here. We only had like the total reported, but now we have the total reported, the hospital admissions, and the total amount of people that died. And basically what I want to do here in this demo is extend this column. So create some extra columns here where we calculate the percentages of people reported compared to the people in the hospital and how many people died. So then we can see sort of percentages there. So that's a pretty nice extension on this demo. So hang on, because I need to build this up slowly, of course, otherwise it's quite hard to understand, I think. So let me try to yeah, build it up a little bit, because it's can be quite complicated. So for instance, here I'm calculating the percent of people dying. And how do I do that? Now we have a column here with people deceased, right? We have that there. That's column 3, 0, 1, 2, 3, right? So I refer there to 3, and I divide it by the column 1, so that's the total amount of people, and then you get the percentage there. So let me see there. It will be a fraction, I think. So we need to. Oh, hang on. It's running. So wait a little bit for that. So now we get an array back. Looks very intimidating, an array, but basically this means 0.01. So that means 1.3%, something like that. So, but we'll fix the formatting on that. No worries. We can do that with Python. So now we have the percentage of people dying for each province. Okay. So let's extend this a little bit, and now we're going to calculate how many people are dying in the hospital. And it's not a valid statement, by the way. It's the amount of people in hospital. It's not dying there. It's the amount of people in the hospital, percent in hospital. So that, again, that's basically just in hospital, and we divide it by the total amount of reports, and then we can percent in hospital. Let's see if we get something back, and we do. So we also have now the percentages of people that are in the hospital per province, so to speak. So comment that out. Let's see what we can do more, because we need. Well, we'll create a new cell here, and I will call this variable new. And what it does is basically create a new table based on this province group, but we're going to add some columns. And which columns? The ones we created here. The arrays, right? This array is just a column that will be added to that table. So let's see what we have in new now. If you now look at new, we have still the province, right? We have the total amount reported in the hospital and disease, but we also have now the percentages of people died and percentage of people in the hospital. And if you look at this, it doesn't look like percentages this, right? So we have some formatting for that, so we're going to fix that. And how do you fix that? By setting a format. So you can do on this new table, you can do a set format method, and what it accepts column name, percent died. You can also provide the index number, right? 0, 1, 2, 3, 4 in this case. And then the percent formatter. This is something built in inside of Python. And if we run this again, you will see that now percentage died is nicely formatted here. You see some differences here already. But the percent in hospital, we did not fix that yet. So basically we do the same there. And I'll copy it over because otherwise you see me typing all the time and it's quite boring, I guess. And here we have the percent of people inside of the hospital. So in Drenthe, for instance, there were 23,000 people reported. And the amount that is in the hospital is 406. And if you calculate it on your calculator, you will get this number back, 1.74%. We did it now for a whole table or a whole column at once, right? With this, this here. Here we do the calculation. We save that. That is an array. And you can stick an array inside of a column. A column exists of an array of items. And then we add that here. Here we give it the name of the column, right? Percent died, that's the name, and this is the data that goes inside of that, and there as well. And the data comes from here. Okay? And now we get this nicely overview here, and I think we can do that. So we can, of course, sort on the percent dying. Let's see. So now we have the highest there, one on top, and okay, interesting that Limburg has a lot of the highest death rate. 1 on 50 dies there, so to speak, if you see the numbers here. But also the highest number of people in the hospital. That's interesting, I didn't know that. But if you see the comparison, South Holland there's a lot more people, but a lower percentage. That's quite interesting that you can extract these kind of informations from these files and with this data toolset from Python, of course. Let's see if we can do some more, because I think we're almost there. Yeah, I think we're almost there. So let's do some bar stills on this, barh, and then on which? On province. And of course, I can do it like that, or I can stick in 0, the same. And now we get the bar based on all these numbers we have here in the table. And also the percentages died. There's our very long bars here, for instance, the total sum reported. Oh, I did not mean to do that. Hang on, let me go back here. Yes, this one. And perhaps we can do one more thing here. Perhaps you can only print the percentages of people that died and that were in the hospital. That's a nice one. We can do that. Yeah, and we do that like this. So based on this new table we created some time ago here, we do a selection on 0, 4, and 5. I was too lazy to provide province and percentage died and percentage in hospital, so I provide the index numbers here. If we run this now, you have only the percentages, but still the province. And we can still do the same here. And again, I'm a little bit lazy, so I copy this over. And I run this again. And now we only have like I still have too much data in here. I need to fix that first. Of course, I didn't save it, so that's quite stupid. Doesn't matter. So we'll remove that there and we'll put it behind there. That's no new. You can do a barh there. And let's remove this one. And let's see what we get back now. See, so now it's the percentages that died. And here, yeah, you have a nice overview of the amount of people that land up in the hospital and the percentage of people died. And that's quite interesting, I think. I think North and South Holland, North and South Holland, are the most crowded places here in the Netherlands. I think Utrecht as well. But the bars are not that long percentage-wise. Number-wise, we win. You know, you already seen that here in here Amsterdam, for instance. There's an insane amount of reported, and Rotterdam as well. But you don't see that back in the percentage of people dying. But basically, Limburg, that's not very good. I think most people are dying there, and then North Brabant, most people are dying there, and then. Yeah. And perhaps we can sort this on, should be able to do that on, let's see if we can do it like this. Not 100% sure. No, that won't get accepted. Hang on. We need to sort first. Okay, prepared the syntax a little bit, otherwise you see me typing and troubleshooting. I did it wrong. I need to sort first, of course, and then I sort on the second column here. I do a descending through, then I sort on the first column as well. I'll show you how that looks. We can even do it, we build it up again. So this is the first one, so now we are sorted on one of those columns. What you can do again is sort again on the other one, so now everything is sort of in that order, and then we can still do a barh on the province, I think. Let's see. Yes, you can still do that. And now we have them in sort of order. So you see Limburg, North Brabant, Friesland. So it is basically in that order, so to speak. That, and as you can see, North Holland's very crowded, and it's pretty low on the list. Okay, let's see. Let's go back to this presentation or slides, whatever you want to call it. So yeah, we imported data, displayed information, the hospital versus the death rates. We did some counting, top 10 cities, calculation. Yeah. Yes, I'm satisfied. And then you know what comes, the last slide. And that leaves me to thank you again. And perhaps I'll see you again. Bye.